Deploying generative AI at enterprise scale introduces immediate engineering bottlenecks. Architects have to provision massive compute clusters, evaluate competing foundation models, and establish absolute guarantees around data privacy. To solve this, the AWS AI ecosystem is stratified into 3 distinct tiers. Your choice depends entirely on the level of control your architecture requires. At the lowest level is Amazon SageMaker. You use this tier when your organization needs to build, train, and deploy machine learning models completely from scratch. It provides total control over the underlying infrastructure and algorithms. At the highest level is Amazon Q. This is a pre-packaged, out-of-the-box generative AI assistant designed to automate immediate business workflows and developer tasks with zero setup. Amazon Bedrock occupies the middle tier. It allows engineers to build highly customized applications using leading foundation models without the burden of provisioning or managing the underlying ML infrastructure. To pass the AWS Certified AI Practitioner exam, you have to know how to construct a production-grade generative AI pipeline from first principles using this specific Bedrock layer. Ultimately, architects must match the service's abstraction layer to the specific technical and business constraints of the workload. Amazon Bedrock operates entirely as a fully managed serverless service. There are no EC2 instances to provision and no compute clusters to monitor or scale. It abstracts the mechanical complexity of different AI providers by routing your requests through a single unified API. Behind this API sits an array of top-tier foundation models, giving immediate access to Amazon Titan, Anthropic's Claude, and Meta's Llama 2. Because the infrastructure is serverless, the operational economics follow a strict pay-as-you-go pricing structure. The fundamental billing metric in Bedrock is the token. Costs are calculated precisely by the volume of input tokens you send to the model and the output tokens the model generates during inference. This completely inverts the traditional machine learning cost model. Instead of paying for persistent cluster uptime, you only pay for the exact text or data processed. By stripping away capacity provisioning, Bedrock shifts your engineering focus toward prompt engineering and application logic. Even the most advanced base foundation models share a critical limitation. They have zero awareness of your organization's proprietary, real-time, or domain-specific data. To bridge this gap, architecture diverges into 2 distinct solutions: retrieval-augmented generation and fine-tuning. Retrieval-augmented generation, or RAG, utilizes Bedrock knowledge bases to dynamically inject factual, external context into a query before it reaches the model. The defining characteristic of RAG is that it does not alter the underlying model's structure or weights in any way. It simply provides the model with an open book to read from. Fine-tuning is the alternate route. You use this process when a model requires a permanent structural change to its baseline behavior, tone, or output formatting. Fine-tuning requires a structured, labeled training dataset stored in Amazon S3. This data is used to systematically overwrite and permanently alter the internal weights of a private copy of the foundation model. A strict operational constraint for the exam. Deploying a fine-tuned model in Bedrock requires purchasing provisioned throughput to guarantee consistent inference capacity. The decision rule is absolute. Use RAG for dynamic, factual data retrieval. Use fine-tuning to permanently embed domain-specific behavior directly into the model's architecture. A standard generative model is passive. It can generate text or write code, but it cannot natively execute actions or interact with external systems. Amazon Bedrock agents bridge this divide. They are orchestration engines designed to automate complex, multi-step enterprise tasks. You configure these agents to securely invoke your company's internal enterprise APIs. The backend logic and real-world actions required by the workflow are executed using AWS Lambda functions. An agent can read a complaint, query your inventory database, and trigger a refund API, all without human intervention. The agent automatically manages the state of the task, using the foundation model's reasoning to sequence the API calls in the correct logical order. By combining reasoning with execution, Bedrock agents elevate GenAI applications from simple conversational interfaces to fully automated operational workers. Deploying foundation models without strict security boundaries is an organizational liability. Enterprise compliance dictates absolute control over data flow. Amazon Bedrock enforces a strict privacy baseline. Your customer data, prompt inputs, and proprietary fine-tuning data are never used to train the base public models. At the application layer, your first line of defense is Amazon Bedrock Guardrails. Guardrails act as highly configurable safeguards. They detect and filter toxic content, automatically redact personally identifiable information, and minimize model hallucinations before the user ever sees a response. Below the application layer, you have to secure the network. This requires establishing a virtual private cloud, or VPC boundary. Architects use AWS Private Link to securely connect an enterprise VPC directly to Amazon Bedrock. This ensures your API calls and data payloads traverse the AWS global network exclusively. They never touch the public internet. Finally, AWS CloudTrail sits over this entire ecosystem, providing continuous auditing and logging of every API call made to Bedrock to satisfy compliance reporting. A production-ready AI pipeline only exists when the intelligence of foundation models is bound by native AWS networking and governance tools. When we zoom out, the architectural stack operates in complete harmony. An enterprise prompt originates from the end user, traveling through the isolated private link VPC, and immediately passes through the Guardrails filter. Depending on the task, the prompt pulls factual context from a knowledge base via RAG or hands execution logic off to a Bedrock agent. Only then is it processed through the unified Bedrock API into your chosen foundation model to generate the final response. This entire sequence executes within a fully managed serverless framework built precisely down to the token. Mastering this specific architectural stratification, knowing exactly where Bedrock sits, how it accesses data, and how it is secured, is the primary requirement for the AI Practitioner exam. Amazon Bedrock integrates generative AI as a secure, functional component of modern cloud architecture.